One of the first questions kids would always ask is, how strong are these things that you're printing, you know? And we've got a couple Yoda statues that people have done over the years, and kids would always say, oh, how strong are these Yoda statues? You know, are the ears that are really pointy and small, are they going to snap off if we print some? And you know, I could tell them, but I would always default to, well, why don't we find out? Give them some glasses, safety glasses, and a hammer, or get them to jump up and down on things. And so we've had some really fun moments in here, especially with kids sitting there with hammers, smashing the hell out of all this 3D printed stuff. And to me, that's like the most enriching thing in the world. I love it. Partly because this is like trash. This was a test of printing in one layer. And like people will say, oh, shouldn't this be kept for the sake of posterity, or shouldn't this be? I'm like, no, you know, this is trash, right? And the idea that everything that comes out of here should be revered or something, I don't know, that's crazy to me. There's no reason why kids shouldn't be able to take a hammer to a 3D printed object and smash the hell out of it. That's like, so I've received I've attained a ton of value from doing that, from like having kids in here smashing things. Always lots of fun. I used to take this around to a lot of events around the city, particularly events with kids, and then events at libraries, because libraries, you know, especially in 2010-ish, 2011, were being told, oh, you all need 3D printers, right? And this was before Toronto Reference Library got the Digital Innovation Hub, and you know, a lot of libraries were being, you know, told, hey, if you want to stay relevant, you need to be teaching digital literacy. And one of those digital literacy skills is understanding, you know, things like 3D printers. We don't really like fetishize a lot of the things around here, so we kind of treat them a little bit rough, as you can see. And in this particular case, I would like lug this thing around, put it in a backpack, put it on my skateboard, and like skate it around town. So it's always getting banged around. Originally, the electronics platform is designed to be built on the underside of this, which is extraordinarily challenging to open up, and then not only open up but put back in. So I thought, okay, this is a pain. Somebody had ordered or brought in all of these boxes. I thought, okay, I got one kicking around. Well, maybe what I'll do is take some pieces of laser cut wood, stitch them together, and create a kind of little platform in here where I now have a sort of suitcase for carrying electronics when I go around. It did sort of two things. Number one, it made it easier to fix any of the like myriad problems that would always, anytime we take this thing out of the lab, there was some problem that would come up. A wire would come loose, or like something wasn't functioning right. And it was always the case, and you couldn't tell if it was software or hardware. Over time, you'd figure out, you know, what it is that's going wrong, but it was much easier when you had access to the electronics in the back. And the nice thing about having the electronics open was it was much easier to troubleshoot as it's going. You know, you could sit there and like unplug something, plug it back in while the thing is on and working. And then the other thing it did was open it up as, you know, almost this like, I mean, this is going to sound corny, but almost like an epistemic object. You know, you're sitting there with kids and you're saying, okay, let's learn a little bit of, or let's talk a little bit about how electronics interfaces with this. It's not really an analog, you know, this is a Cartesian robot, right? But it's not, so it's not really an analog thing, but there's an analog sort of process going on here, right? You're melting plastic, right? You're not melting bits, you're melting plastic, and you're drawing with plastic. So it was this interesting way of kind of describing how the material and digital world are colliding here with kids, right? And having this conversation with them while we were out at some different events. So it served this kind of second purpose of being able to like provoke conversations about, you know, electronics, or let's say the digital raw material that the 3D printer uses. Some of this sort of stuff came up quite a bit. So fortunately, well, kind of unfortunately, with most of the newer machines, which really, especially with Makerbot, really are black boxes, and they've increasingly gone that kind of black box route, and really a sort of press a button, it will print model, where, you know, previously this required a lot of not really tacit expertise or knowledge on the part of the operator, but you really did have to get your hands dirty and know when, why and how something might fail. You had to spend a lot of time figuring it out. Where with those ones now, they push a lot of that expertise through the software. So when there's, if the temperature needs to be adjusted by a degree or two, and you as an operator know that, in the past you would do that in a control panel. Now that's pushed through the code that the machine uses to render something as a printable object, right? And that's increasingly their model. The Makerbot got bought by Stratasys, one of the biggest, if not probably the biggest 3D printing manufacturer in the world. And Stratasys just said, no more of this like backroom hacker crap. We're going in the direction of, expertise, engineering expertise. And so that's, now you just see these kind of custom push button solutions. It took a long time, mostly because I didn't want to do it in sort of one fell swoop. I wanted to like spend, so I spent probably 3 weekends just coming in after hours, tinkering around and putting it together. The instructions were garbage, they always are, and you always have to modify something. You spend more time on the forums looking at conversations that people have had about fixing little things, right? And that was the most informative part of it. I had to learn how it worked. I had to learn, I had to learn not just how it worked by pressing a button. I had to learn what was actually going on. I had to effectively take apart the black box, right, or go into the black box. And in that sense, it was really valuable. So it took me a few weeks to get it all together, but that was just because I wanted to spend the time doing it right and figuring out like every little part of it and knowing why every little part of it, functions the way that it does. And to be honest, that ability to do that is something that, I certainly can't take credit for it around here. It's something I've always, had. Anytime I want to learn a new thing, I've always just sort of spent the time doing it. But it's a kind of, let's say, tendency that I think a lot of people who work here have, where we will go to war with these kind of machines. You have to beat the printer. You cannot, get 90% of the way finished and then something's not working and you walk away. You have to win. This is like the eternal like hacker battle, right? Make it work. Debug it until it's, until there's no choice. That's basically what I did. Little things weren't working. I had to make little hacks. There's some hockey tape on here because this the extruder assembly that it sits in was slightly off and causing prints to fail, and I thought, okay, what can I do around here? What do I have at hand that's that can work and will work for a long time? And I was like, oh, perfect, hockey tape, right? And so it's those little things where it was a pain to put it all together. It wasn't a pain to put it together. It was a pain to get it working, but it was valuable in the long run to take the time doing it, because once I knew how this thing worked, it was I instinctively knew how every one of the machines that followed also worked. It's acquiring a sort of not even a proficiency, acquiring a sort of literacy for the medium of 3D printing and the mode under which that medium is enacted, or through which that medium is enacted. And by doing that, it just it made it much easier for me to understand how all those replicators work, and then understand how the industrial grade machines work, and then understand these big stupid ones and what's happening there. And for some reason, printing has been the sort of medium that we end up using a lot for a variety of different projects here.